Hello, my name is Benjamin Cole, and this is my presentation for the course project for Math 2269 Bayesian Analysis. So the data I used was a data table from data.gov.au, which contained the number of payments made by the Department of Social Services Australia in 2014. It was broken up by a few different variables. So one of them was payment types. So that was payment types such as family tax benefit, Oz study, healthcare card, youth allowance, pension, widowers tax benefit, all those sorts of payment types. It's also broken up into federal electoral division and state. So there was one metric response variable and several categorical predictor variables. So because of the nature of the data, I ended up choosing Bayesian ANOVA. So I used amount as the response variable and payment type and state as beta 1 and beta 2 categorical predictor variables respectively. So I ended up not using federal electoral division because it was kind of redundant. Only one federal electoral division can belong in one state. It can't belong over two states basically. For the X1 contrasts, I chose those levels based on the similarity of the homogeneity within the group. So family tax benefit A, family tax benefit B, and healthcare card all had very similar distributions. That being said, payment type in general was very heteroscedastic. And for the X2 contrasts, I just chose the most populated eastern states in Australia, so Queensland, New South Wales and Victoria were chosen. Because the data is, at least in the beta 1 group, so heteroscedastic, I ended up choosing a robust heterogeneous model for this analysis just so that it would be somewhat resistant to that heteroscedasticity. So here we can see the distribution of the payment amounts is quite heavily skewed to the right, quite positively skewed. And that's just the way the data has been structured. Unfortunately, some of the data observations were changed from a value of like 15 or 10 to less than or equal to 20. And that was due to privacy concerns and privacy of the data. But that wouldn't really change the distribution. It would still be quite heavily skewed to the right with a very long tail. So the distributions of the payment amounts by payment type is shown here. So as I was saying before, there's quite a lot of heteroscedasticity within this group across the different levels. Family tax benefit A, B, and healthcare card were the three levels chosen as the main contrasts for X1, and that was because all their distributions were somewhat similar and they weren't too close to zero, which was nice. The distributions of the payment amounts by state are all somewhat similar. They're all heavily right skewed, quite positively skewed, so I just ended up choosing New South Wales, Queensland, and Victoria. So the chains that I had to run for this simulation had to be really quite long with large burn-in periods and a large amount of thinning to achieve convergence. So unfortunately, these did take quite a while, but that's okay, we got there in the end. And they ended up being somewhat accurate as well, which is good. So you can see, just for brevity, I'm just showing you the beta 1 contrast, the beta 1 diagnostics, and you can see that, it all kind of hovers around a certain value of centrality with a few deviations, but it's mostly hovered around probably about 20, maybe about 30,000 there actually. The effective sample size was quite large, but that was only because I had to thin quite a lot. I think I was thinning about 1 in 15 or 1 in 20 steps, so it was thinning quite a lot of the data. I'm not too sure why the shrink factor isn't showing. I think it's just because there were so many observations that it's just the software can't build the plot, or my processor on my computer, my graphics card just can't process the plot because it's so large. But we can see, like, regardless of the shrink factor, it pretty much says the same thing here, is that the Monte Carlo standard error is really quite low. You can see the chains have overlapped really well, so it shows quite a lot of good convergence. And all of the other diagnostics look somewhat similar to this, and they all achieved convergence. So the posterior distributions for the after the chains were run all kind of look like this. So this is the payment types, the posterior distributions of each payment type within the state of Victoria. And we can see here, these are our X1 contrast, so family tax benefit A, family tax benefit B, and healthcare card, and they sit somewhat in a similar sort of area as the likelihood. And that was essentially because for the prior distributions of the spread of the beta 1 and beta 2 deflections, I ended up using gamma distributions of the sampling space, and that was because it was not provided with any expert knowledge, so I just had to go with what I had, unfortunately. And also I ended up squaring the value of that gamma distribution rather than just using the straight output, because gamma was giving me far too much variance or far too much uncertainty, so I ended up reducing it by taking gamma squared, and that gave me a much more accurate estimate, at least in my opinion. So improvements, the data set was really quite heterogeneous. There's quite a lot of variance, especially within payment type. So this might be improved by filtering the data to just observe the payment types that I was interested in, so family tax benefit A and B and healthcare card. But if I was to do this, I would lose quite a lot of the other data, which was also important as well. The simulation took quite a long time, as the chains were quite long and they required quite a lot of thinning and they required a large burn-in period, which also might be improved by filtering the data, but also same sorts of issues as I just mentioned. There was no expert knowledge provided with this data set that I could use to explore the priors. I could have emailed someone that works at the Department of Human Services or Department of Social Services, but I guess I just didn't. So I ended up using the sampling distributions to estimate my prior distribution. So to improve this, I could just take guesses on the prior distributions, and those guesses could be made with weak to moderate certainty just to explore what sort of effect the priors would have on the posterior distributions. So that's my presentation for the final course project. Thank you for listening.